Welcome back, pre-algebra students. We are in lesson 106, and we're going to talk a little bit about roots of negative numbers. Remember that every positive number has a positive square root. Also, every positive number has a negative square root because 2 times 2 is equal to 4, but negative 2 times negative 2 is equal to 4 as well. When we write the square root of 4, we indicate the positive square root of 4, which is 2. When we write negative square root of 4, we are indicating that we want negative 2. Negative numbers do not have positive square roots or fourth roots or sixth roots because we know when we have negatives multiplied in pairs that the answer is going to be a positive. So we can only have a negative square root or a negative root whenever we have a odd number in the index. For instance, 106.1, we have the problem, the third index of negative 64. So we know that that is going to be negative 4 because negative 4 times negative 4 times negative 4 is equal to negative 64. So these are our three factors that are all negative that give us a negative 64. So we can have a negative underneath our square root sign if we have an odd number index. That's what we're looking for. Let's try 106.2. So here we have the fifth index of negative 32. And we know that we can multiply negative 2 5 times, and that's going to give us a negative 32. So therefore, the answer here, the third index of negative 64, is going to be negative 4, and the fifth index of negative 32 is going to be negative 2. Because 1, 2, 3, 4, 5, identical factors that give us a negative number. But that only works, negatives under the radical, only works if we have an odd number index. All right, so let's look at negative exponents. What? Yes, exponents can be negative. Here's how. Remember scientific notation. When we have 1.5 times 10 to the negative 3, we know that this negative sign in our scientific notation tells us that we're going to move the decimal point to the left 3 places. So this would equal 0.0015 because we moved the decimal place 1, 2, 3 spots, right? We know that's the answer and we know that's how to write that. But did you know that you can do the inverse operation here and put this in this format and get the same answer? So we know that 10 to the 3 is 1,000. And when you divide that with your calculator, let's let it come up. If you take 1.5 and divide it by 1,000, you get the same answer. Isn't that cool? So we know that this negative sign is just telling us to do the inverse operation with this exponent. It's the same number. So what that means is when we have this happen, we can invert this instead of trying to count the decimal places, which to me is actually faster. You don't have to convert it and then convert it again. You're just moving the decimal places. You can do it like this too. You can rewrite it like this. Do the multiplication. We know it's just going to be 1 and 3 zeros because that's our exponent of 3. 1 and 3 zeros divided by that number and you get the right answer. So if you need to check your scientific notation result whenever you multiply it out, you can do it this way. This is a great checking method for scientific notation. So checking your scientific notation like this is a smart idea. Okay? Check scientific notation by putting this below. When you move it to the bottom, you change the sign from a negative to a positive. That works for every other situation as well. So, for instance, if we have 10 to the negative 5, we can turn this into a fraction and say 1 over 10 to the 5, which then equals 1 over 1 and 5 zeros, which is 100,000. If we have 10 to the negative 2, we can say 1 over 10 to the 2. Because remember, in this regard, we're asking for the inverse operation. And the inverse operation of multiplication is going to be division. So that's how that works. So we know this is going to be 1 over 100. Right? And then when you do the division, that tells you the number of decimal places. And it's just the number of zeros that you have is the number of decimal places. So if we do another number, does it work with other numbers besides 10? Yes, it does. We can use it with any number we want to use it with. So I have 3 to the negative 3. That becomes 1 over 3 to the positive 3. Now, when you have a positive exponent, you can solve this. We do not leave this with the exponent if we have a whole number that can be solved. So 3 times 3 is 9, times 3 again is 27. So the answer here is 1 over 27, not 1 over 3 to the third. Go ahead and solve what you can solve whenever you have a problem like this. So if we had 7 to the negative 8, that answer would be 1 over 7 to the 8th power. And you can do these big numbers on your calculator that you can't do in your head. Just pull it up. And there's a little button right here that says X to the Y. So let me clear this. You can type in 7, tap the X to the Y button, type in your exponent, and then press your equal sign, and it will tell you what that number is. It's a huge number. So that would be 1 over, what was that? 5,764,801. So 5,764,801. Right? So you don't have to calculate that yourself. You can get some help with that by using the calculator. And it does have that shortcut, and it's so nice to have that shortcut in there. All right, so let me show you something else with that. You can also do negative exponents. So you could say 7, XY key, 8 negative equals, and it gives us this big long decimal, right? I'm just going to put down 1, 2, 3, 4, 5, 6, and then 1, 7, 3, 4. All right, so 1, 2, 3, 4, 5, 6, and then 1, 7, 3, 4. And I'm not going to try to remember the rest, but I want to show you on the calculator that if we take this number here that we got by switching it to a fraction and said 1 divided by, and that was 5,764,801, it's the same number. Look at that. 1, 2, 3, 4, 5, 6, 1, 7, 3, 4. And then I didn't write the rest of these down because I couldn't remember them all. But it's the same value when we change this negative sign to a positive through the act of the inverse operation, which goes from multiplication to division. All right, let's try some practice problems here. I'm going to clear the page. And let's try 106.3. So we have 1 over 4 to the negative 2. Well, we know that if it is on the bottom or the top, if we flip it, the exponent becomes positive. That's what we want to do. So this becomes 1 times 4 squared. which we know is 16. So 1 times 16 is 16. Easy peasy. It doesn't matter whether you're moving it from the bottom to the top or the top to the bottom. Wherever it is positive, when you move it, it becomes negative. And if it is already negative, when you move it, it becomes positive. So you're just flipping the sign when you go from the denominator to the numerator or the numerator to the denominator. So let's try 106.4. We have 1 over negative 2 to the negative 4, right? So we have a negative number, a negative integer, with a negative exponent. So when we flip it, what happens? We keep this negative integer here. This stays the same. The negative on the integer does not change, only the exponent changes to a positive. So we can answer this by saying negative 2 to the 4th power, which is going to be positive 16, because we know 1 times negative 2 times negative 2 times negative 2 times negative 2. We have 4 pairs of negative numbers, and that's something you can judge just by looking at your exponent. If your exponent is even, you're going to have a positive result, because remember, pairs of negative numbers make a positive. So 1 times negative 2, that's negative 2. That's going to be a positive 4, negative 8, positive 16. So that is our result. So let's look at one more, 106.5. And here we have a negative 1 over negative 3 to the negative 2. So first we need to address the negative exponent, because PEMDAS tells us that the exponents come before multiplication and division, right? So we reformat this to be negative 1 times negative 3, and we get rid of the negative sign only on the exponent. It stays with the integer. Okay, now we can write this out so we can see it better. Negative 1 times negative 3 times negative 3. Now we have an odd number of negative signs, so we know the answer is going to be negative. 1 times 3 is 3. 3 times 3 is 9. We know it's a negative 9 because of the odd number of negative signs. And that is how we would solve that. Okay? Keep your negative sign, even if your negative sign is out front of your problem when you see it on your test paper. The denominator of a number, we never put the negative sign there, because the denominator is just telling us how many goes in that set. And if we have less than what we need to make the set, this is what tells us that. We don't have any. In fact, we owe 2 more to somebody else. So that would be what the negative means. So the negative is always attached to the numerator, never the denominator, unless you specifically see a problem that has the negative sign on the numerator and another negative sign right down here in front of the parentheses. But if you have the negative sign right out front of the fraction itself, we always attach that to the numerator. All right, I hope that clears that up for some of us. So let's talk about what happens if our exponent is 0. I hope you've written all of these down for examples. If not, pause and do so. I'm moving on. When our exponent is 0, we know we can't do anything with that. We know a non-zero number divided by itself equals 1. So for instance, if we have 4 over 2 divided by 4 over 2, that's just 16 over 16, which would be 1, right? So let's look at it a different way. If you have 4 over 2 divided by 4 over 2, and we take this exponent, this denominator, we flip it to the top, that becomes 4 to the 2 times 4 to the negative 2, right? Well, when we have exponents that are multiplied with the same base, we have the same base multiplied, we know the rule tells us that we can add those exponents with the same base together. So we could say 2 minus 2. Well, isn't that 0? 2 minus 2 is 0. So, by that example and this example, we know that 4 to the 0 is just equal to 1. That tells us why we can say any number to the 0 exponent is just equal to 1. And then that also applies whenever we have variables. So if I had x squared, or let's just say I had x cubed for the sake of argument, I have x cubed over x cubed. When I bring this to the top, that's going to equal x cubed times x to the negative cube, which we know is x, 3 minus 3, which is equal to x to the 0, which is equal to 1. So when you see numbers or factors that are above each other that are the same, they have the same exponent, we can actually factor them out and call them 1, or we can bring them to the top and subtract them from one another, and it works out. But anytime you have any number or variable to the 0 power, that particular base that the 0 is attached to is equal to 1. And that is a fact. So let's try a couple of those practice problems. So let's do 106.6. Here we have 3 problems. So A is 2 to the 0, and B is negative 2 to the 0, and C is negative 2 to the 0. All right, so we know that any number to the 0 is going to be 1. So this is 1. That's all that is. It just equals 1. Negative 2 to the 0 is attached. We know this is the same thing. The 0 is attached to the 2, not the negative sign. So we know this is the same thing as negative 1 times 1. So this equals a negative 1, because this negative sign is not included with the exponent. But here in C, it is. 0 is on the outside of the parenthesis, so the negative is included. So when we have a negative 2 or any negative number inside parenthesis with the 0 on the outside, that's going to equal 1, because it doesn't matter if it's negative. All right? The exponents have canceled each other out, and they balance and are now equal to 1. So let's try another one, 106.7. Here we have some variables that we're going to practice on. So I have x squared, y to the 5th, y to the negative 2, and x to the negative 2. All right, so let's start by putting like terms together. I like to use the stacking method that I've talked about before. So I have x squared here, that takes care of that one. And then I have y to the 5th, that takes care of that one. Now I have y to the negative 2, so I'm going to subtract 2 here, takes care of that one. And I have x to the negative 2, so I'm going to subtract that from that exponent here. So 2x2 minus 2, well, that's x to the 0. So that's x to the 0, and then this would be 5 minus 2, y to the 3. So that's the same thing as saying y 1, because that's what the x to the 0 is, times y to the 3. We know that every variable has an invisible 1 in front of it anyway, so that allows us to drop the 1 and just say that our answer is y to the 3rd power. And that's what we would write for 106.7 as our answer. All right, if you have any questions about that last problem, let me know. I can explain it further if you need me to. But that is all we have for lesson 106. So remember that any time we have a negative exponent on the top in the numerator, and we can move it to the denominator and make it positive. If we have a negative exponent in the denominator, we can move it to the numerator and make it positive. If we have exponents that subtract to 0, any number with an exponent of 0 is equal to 1, right here. And whenever we have a exponent of a variable that drops away and becomes a 1, we don't have to write it. We can just eliminate it completely from our answer because we know there's an invisible 1 right here at all times. And we also know that 1 times anything is itself, so we don't have to multiply it. We can just drop it. All right, that's all I have for lesson 106. I'll see you in 107.